In this video, I'm going to solve few questions that are related to the topic remainder factor theorem, quadratic inequality, and nature of the roots. So this is kind of a worksheet that you can solve by yourself as well. You can just stop the video and solve these questions by yourself and then see the answers and solutions. So the very first question over here, it says the polynomial is ax cubed minus 9x squared plus bx minus 6, where a and b are constant, has a factor of x minus 2. This is the important point. The polynomial has a remainder of 66 when divided by x minus 3. Find the value of a and the value of b. So coming back to the very basic maths, since we need to find out the value of two unknown constant a and b, so we need to have two equations in terms of a and b. So what I'm going to do, this question is a part of remainder factor theorem. What I'm going to do, since x minus 2 is a factor of this polynomial, so I'm going to equate this x minus 2 with 0, and I'm going to get the value of x is equal to 2 here. I'm going to put this x value 2 in the polynomial. This is what we do in the remainder factor theorem. After putting up this value x equal to 2 in the polynomial, I will get the remainder. So this is going to be called as remainder, which is 2 cube 8a, 2 square is 4, 4 9s are 36, 2 into b is 2b, that is minus 6. So remainder over here is 8a minus plus 2b minus 42. Since x minus 2 is a factor here, so I can say the remainder is going to be 0. So I'm going to equate my remainder with the 0 here, since I also got the remainder when putting the x equal to 2, which is a factor. So I'm going to equate it with the 0. I'm going to take 2 as a common, it becomes 4a plus b minus 21. 2 is going to be divided by 0, it becomes 0. 0 divided by 2 is 0. 2 is going to shift on the left hand side, 0 divided by 2 is 0. So that's why I'm not writing 2 again. I'm going to make b as a subject now. So 21 minus 4a is b over here as a subject. So I got the first equation here now. Now for the second equation, I'm going to use the second hint. When it says x minus 3, when divided by x minus 3, so x minus 3 is the divisor. I'm going to equate the divisor with 0. I'm going to get the value of x now again. I'm going to put this x value in the polynomial, that is a into 3 ka cube minus 9 into 3 ka square plus b into 3 then minus 6. So I'm going to have this thing. When I put the value of x equal to 3, I'm going to have the remainder. This is what the remainder factor theorem says. So I'm going to have 27a, 3 is a 9, 9 9 is 81, t square 9, 9 is 81, 3 into b is 3b, then it is going to be minus 6. I'm going to have remainder as 27a plus 3b minus 87. Since when you put the x equal to 3, you got the remainder 66. So I'm going to equate this remainder with 66. I'm going to have 66 is equal to 27a minus 3b minus 87. I'm going to move this 66a on the right hand side. It becomes minus 66. It is going to be minus 153. 153. I'm going to take 3 as a common. 150 divided by 3 is going to be 51. So I got 0 divided by 3 is 0. 3 is going to be divided on the left hand side, becomes 0. 9a plus b minus 51 is the second equation. Now from the first equation, I'm going to put the value of b is 21 minus 4a over here. I will get 9a plus 21 minus 4a minus 51. 9a minus 4a is going to be 5a. 21 minus 51 is going to be minus 30. After simplification, I'm going to get the value of a, which is 6. Once I got the value of 6, I'm going to put it over here in the very first equation. So b is equals to 21 minus 4a and b is equal to 21 minus 4 into 6. 21, 6, 4 are 24. The value of b is going to be minus 3 here. So you got the answer of a and b for the very first question. Let's just minimize it. Right. Using the values of a and b show that p x is x minus 2 into qx. See, you know this px over here is a cubic function. It is a cubic function. If we write the value of a, it is going to become px is equals to the value of a is 6x cube minus 9x square, b value is minus 3, it is going to become minus 3x minus 6. So when you factorize this, you will get something like this. Px is equal to x minus 2 into qx. That's what they are saying in question in part B. See, when you factorize this cube expression, you will get x minus 2 into qx, where they are also mentioning that this qx will be a quadratic factor, and that's what we know. Then when you factorize a cubic expression, it is going to break into a 3 linear expression or into 1 linear and 1 quadratic expression. So this is a linear expression. The qx should be a quadratic factor here. So we need to find out this quadratic factor. How we are going to find it? So first thing first, we should know we are going to do the synthetic division here to find out the other factor that is a quadratic factor. I'm using the synthetic division. You can also use the long division method. What I'm going to do, I'm going to write the coefficient of the polynomial here, which is 6, minus 9, minus 3, and minus 6. I'm going to write this x minus 2 is equal to 0, and I'm going to get the value of x over here, which is 2. X minus 2 was a factor in the previous question. They have already said this. What I'm going to do, I'm going to write the 6 as it is over here. This is the part of the synthetic division. 2, 6 are 12. I'm going to add this. Minus 9 plus 12 is 3. 2 3 are 6. Minus 3 plus 6 is 3. 2 3 are 6. Minus 6 plus 6 is 0. So obviously we know this x minus 2 is a factor, so we will get the remainder 0 here. But what is the quotient? So you're going to write x power 0, x power 1, x power 2 here. The quotient is going to be 6x square 3x into 3. This is the quotient. So like you know, x minus 2 is one of the factor. After division, the quotient is going to be the other factor. So this is the value of qx here, q of x. This is, you can say, second factor. The other factor, which is a quadratic factor, is this one, the quotient here. The q of x is 6x square plus 3x plus 3 here. This is your final answer of this question. Now in part C says, hence show that the equation p x equal to 0 has only one real solution. Since you know that you have factorized this expression, you have factorized this expression. If you just put it equal to 0, px is this one now. So you can just put this px is equal to 0, and this is how it is factorized in the previous part. X minus 2 into qx. Qx value was 6x square plus 3x plus 3 is equal to 0. You have to show that it has only one real solution. So you can see you have two brackets equal to 0. You can separate them. X minus 2 equal to 0, x equal to 2. This is one of the real solution. So what about the second bracket? You have to show this thing in the second bracket that this will not result into a real solution. How you are going to show it? With the help of discriminant, which is equal to b square minus 4ac. You have to show that discriminant is less than 0. So value of b over here is 3. Value of a is 6. Value of c is 3. This is the discriminant. If you just find out the value of discriminant, 3 square 9, 6 4 24, 24 into 3, it is going to be 72. 9 minus 72 is going to be minus 63, which is less than 0. Since discriminant is less than 0, so over here no real roots from here. So we have proved there is only one real roots. This is the real solution. And since from here we have got discriminant less than 0, there isn't going to be any real roots. Now in question number 2 it says, find the possible values of k for which this equation has real roots. So this is the question from the nature of the roots purely. So it says find the value of k when the equation has real roots. So when it says equation has real roots, you're going to put discriminant is greater than 0. You're going to directly put the discriminant is equal to 0 or greater than equals to 0, because when discriminant is equal to 0, roots are real. When discriminant is greater than 0, roots are also real. So what is discriminant? Discriminant is going to be e square minus 4ac. I'm going to put it greater than equals to 0. What is the value of b? B value is k plus 5 whole square. What is the value of a? Value of k, a is k. Value of c is minus 4, greater than equal to 0. I'm going to simplify it. K square, 2 5 are 10, 2 into k multiplied by 10k. The answer, it is going to be 25. Minus 4 multiplied by 4 is going to be plus 16k is greater than equal to 0. I'm going to simplify it. Minus 10k plus 16k, it is going to be minus 6k plus 25 is greater than equal to 0. Now what I'm going to do, I'm going to break the middle term. This is plus 610k and this is going to be, sorry, it is going to be plus 10k and this is going to be 26k. So I'm going to break the middle term, which is going to be 25k plus k plus 25 is greater than equal to 0. I'm going to take common k plus 25, take one common, k plus 25. I'm going to have k plus 25, k plus 1, 2 brackets greater than equal to 0. For a short time, what I'm going to do, I'm going to write k plus 25 and k plus 1 is equal to 0. I'm going to get the value of k, which is minus 25, which is minus 1. I'm going to get two values of k, right? Once I got these two values of k, but this was not the question. The question is find out the value of k when discriminant is greater than equal to 0. This quadratic equality is greater than equal to 0. So when the quadratic equality is greater than equal to 0, just a short sketch. These are the two k values here. This one is minus 1, this one is minus 25. So since the inequality is greater than equal to 0, I'm going to write this is the portion where it is greater than 0, greater than equals to 0. So what at what k values? K is greater than minus 1, k is less than minus 25. So my answer is k is greater than minus 1, k is less than minus 25. Since it is equal to 0 as well, so I'm going to write k is greater than equals to minus 1, k is less than equal to minus 25. This is going to be your final answer. Now it says do not use a calculator in this question. Find the remainder of px. We need to find out the remainder of this when px is divided by x plus 1. I'm going to write x plus 1 is equal to 0 and I'm going to get x equal to minus 1 here. This is what the remainder factor theorem says. The divisor should be equal to 0. You put the divisor equal to 0 and get the value of x. Now you're going to put this x value 1 minus 1 in the polynomial. Now this, when you put this value minus 1 in the polynomial, you will get the remainder. So minus 1 cube is minus 1. It is going to become minus 15. Minus 1 square is plus 1. You're going to get plus 22. It is going to become plus 15. Minus 15 plus 15 is 0. Remainder is going to be equal to 24. So that x plus 2 is a factor of this. If x plus 2 is a factor of this, I'm going to repeat this step. X plus 2 is equal to 0. Put this x plus 2 expression equal to 0 and get the value of x, which is minus 2. I'm going to put this value minus 2 in the polynomial. Minus 2 cube is minus 8. Minus 8 into 15 is minus 120. Minus 2 square is 4. 4 multiplied by 22 is going to be 8. 88. Minus 2 into minus 15 is going to be plus 30. Plus 22. This will result into a remainder. So minus 120 plus 88 plus 30 plus 2 is going to be 0. Since you have to write, since remainder is 0, x plus 2 is a factor. Write Px as a product of linear factors. So you can see we have to write this Px into a factorized form, into a linear factors. So what I'm going to do, I'm going to divide it. Since I got the first factor here, x plus 2, so I'm going to divide it with the synthetic division to get the other factor, that is the quotient. So I'm going to write the coefficient in the descending order of x power, that is going to be 15, 22, minus 15, plus 2. I'm going to write the first factor x value. From the first factor, the x value is minus 2. I'm going to write 15 as it is. Minus 2 into 15, minus 30. Minus 30 plus 22, I'm going to add these values. It is going to be minus 8. Minus 2 into minus 8 is going to be 16. I'm going to add them. I'm going to get plus 1. Minus 2 multiplied by 1 is minus 2. I'm going to add them. 0. The last thing over here is remainder, which is obviously going to be 0 because we are dividing with a factor. Now this x power 0, x power 1, x power 2. Now 15x square minus 18x plus 1. This is your quotient here. The quotient is the other factor. So you can say 15x cubed plus 22x square minus 15x plus 2 can be written in a factorized form, x plus 2, one of the factor, and the other factor is 15x square minus 8x plus 1. They need all the factors in the linear form. It means it can further be factorized, the quadratic factor. I'm going to factorize it. Minus 5x minus 3x plus 1. I've used the middle term breaking method. 5x common, it becomes 5x. It becomes 3x minus 1. Minus 1 common, it becomes 3x minus 1. I got the three factors, three linear factors. Now, this is your answer, that I've converted the expression into three linear factors here. Now, in the next part, they are saying, hence solve this px equal to 0. So I've got this px in the factorized form now. So I'm going to put this px in is equal to 0 here. This px in the factorized form, I'm going to put this equal to 0 here. Since all the brackets are multiplying and equal to 0, I'm going to separate them. X plus 2 equal to 0. 3x minus 1 equal to 0. 5x minus 1 equal to 0. And I'm going to get the value of x equal to minus 2 here. I'm going to get the value of x equal to 1 by 3, x equal to 1 by 5 from here. This is going to be your final answer. And this is the end of the worksheet.